Welcome everyone for the session on seismic shift for the largest fintech migration. The reason we called ourselves this title of seismic shift is if you step back and look at the overall e-commerce across the world, it's approximately $5 trillion is what we tend to do. And 1/3 of it is what we process typically. And during this migration, a substantial amount of it is what we actually helped it to pass it along. Before the intent of this session is what we wanted to do is we want to celebrate and share our journey of what we have done throughout the last few years. About a year and a half is what we have spent it, how we have used Snowflake as a technology, how we have partnered along with our tech stack to build a solution that should solve the future of payments in general. That's our take on it. Before I start off with any of this session, I would like to thank many of my colleagues, teammates, engineering partners, product, and the go-to-market strategy team who has made this a reality, without whom I don't think so this product, which is actually in life, would have been possible. Good afternoon, everyone. It's my pleasure to be here along with my colleague Corey. I'm Kalyan. We are from PayPal. And folks who, if you don't know what PayPal does, we tend to help facilitate online payments in various forms and aspects, right? There are multiple products that we offer. There is PayPal app in which you can send money and things of that sort. You can buy stuff. There are Braintree APIs, which gives you an API way of interacting, buying stuff, or giving merchant experiences around it. There are Zoom, Hyperwallet, and bunch of things. Overall, all together, we take 1/3 of the global traffic of e-commerce that happens around it. And we try to provide solutions for large enterprises predominantly. That's where we specialize it, or this particular group where we specialize in, but there are also substantial support that we do for SMB merchants too. Let me run down through the agenda. A big part of it is what drive us to do any of this migration, or why did we started integrating with Snowflake. That's what we're going to cover. There are parts of it, how we are trying to do a real-time data processing, how it has helped us. We looked at what our ETLing process, right? You typically have ETL process no matter what in most of your sessions that you do. Most companies would have done that. How we looked at ETLing, which parts we did shrink down, which parts we actually doubled down. We'll try to go through it. Then there are parts where we have done a lot of engineering optimizations, how we build out that platform. We also looked at things that are realistically important to many of us, if you are from an engineering background. Things like how do you do an Xboxing? How do you bring data from a cold storage to a hot storage and try to process it? How do you look at sharding and so on? Probably we'll go into those details. A big part of it does not matter what you do without your analytics. It should have an impact. What is the core impact to your business, to your merchant, to the product that you're launching in? And how we are looking at all other relatively predictive models that we are trying to build out, and how we are looking at use cases that we are building based upon the data elements that we have gone together. That's the last section. I'll run down with more examples around it. But the biggest takeaway that I really want you all to take away is the seamless experience that we are trying to bring in as we are ever changing infrastructure underneath. The whole thing is about to change. What drove us is a partnership that has broken from our previous example. What we are trying to work with a partner, the third party vendor with whom we were working, we have to change it and we have to shift to a different third party vendor. That was actually a triggering point for us to go back and reanalyze, hey, what we are doing, are we able to leverage it? Are we going to leverage it in a geographically bound state? And we are trying to take a solution and deploy it in various regions and still ensure that we maintain the same experience or a slightly better experience that we are giving to our merchants. That's what we are trying to do. A lot of it went into a re-architecture mode. Many of you are leaders in this room for various organizations, whether you are a technical leader, business leader, no matter what. This is not a new story that you have heard it. Something from your upstream has changed, and you are asked by your leadership saying that, hey, get me a solution that is smarter, easier, faster, and cost effective. And pretty much this is the same story that we went through. It's exact the same thing playing again and again. And this is our take about the problem space that we have and how did we solve it. Just for another bit of context, not many of you would have realized it, but in and out, you would have used, our work gets used every day, or it touches everyday lives of many of you. Like, have you ever thought about ordering a coffee or ordering a food from from an app, or else if you have done a ride shares, or if you have streamed any playlist of it, or as mundane as if you paid bills, electricity bills, water bills, gas bills, internet bills, no matter what, or even you have scroll through your social networking sites and you thought, hey, this is something I really want to purchase, or you underneath the hood, these APIs that we provide, those are getting used. The way I tend to call ourselves is as the invisible hand of payments. That's where we are. Everywhere we are present, people don't realize it. That's how we account to such a big economic shift that you're looking at. So coming back to the driving factors of why we started doing it, what was the reason behind it. So a biggest part of it, challenge is how do you manage dependencies as you are trying to shift the entire part of the revenue that is driving our business, approximately 900 billion worth. I'll talk in a minute why that is so massive, right? If you look at it, payments is so interwoven into our daily lives that you always take it for granted. Think about it as you're flying in for this conference itself. The amount of time that you would have spent in trying to book a flight is actually much higher than actually you thought about, hey, how I'm going to pay for it. Amount of time that you have spent across thinking that, hey, which restaurant, what is the flight time, all of these pieces are more important than you are actually making effort to make this payment. That means payment has become a second nature, and it is this most stable system that you take it for granted. And that is happening because a lot of work that goes behind all of these systems. Again, I talked about 900 billion traffic in 3 months. What does 900 billion means to begin with, right? The scale is so massive. To give you some perspective, that's the size of GDP of Switzerland. For a moment, if you look at it, it's the annual GDP of Switzerland. That's what it is. A country that manufactures your luxury watches, right? Impeccable timing. Look at it, the timing. We moved it in less than 3 months. That's what we did. At another viewpoint, if you visualize $100 bill and stack them over, the pile of it is actually taller than Mount Everest, not by once, 125 times. When people say, hey, migrations takes a mountain to move, actually probably moving a mountain is cheaper. If it is taller, if your pile of $100 bill is taller than Mount Everest by 125 times, you're stacking that up. That's what it is. And the last thing that we kept at the center of all of these things is our customer experience. We talk about SLAs and the performance. SLAs means many things to many people, and it's not a jargon that we are trying to throw around. For a merchant or for anybody who has experienced this long waiting queues during Thanksgiving while you're trying to buy stuff, a minute at a checkout experience actually gets replicated exponentially as you stand in the queue. Same thing happens across if you're not a millionaire, somebody who has experienced this toilet paper rush that we all went through during the COVID, it's the same experience. Even if it is an online experience, think about that doom of death cycling or the beach ball experience that you have. I haven't seen anybody who came back and said, hey, I really enjoy watching that beach ball. Nobody likes that. It's absolute delay. It kills your time, does not add a good experience. And that's what we kept in the center of it. We wanted to ensure that we have performant and an SLA-centric, low latency APIs that we wanted to give.
Okay, I get to walk through the architectural diagrams of the journey we went through doing what Kalyan was talking about. And I'm going to start with our original architecture that we started out with. This is greatly simplified so that it could fit on the slide, but also that you wouldn't get too confused of what we have. This says AWS Cloud. We just went to the cloud in all three of these domains at the end of last year. But for context, where we started off with was on the left-hand side, that domain is what we call like our funding application, and that's turning 13 years old this year. So it went from processing $0 a year to processing the $900 billion a year that Colin was talking about in 13 years. So we had a lot of scaling problems, which we'll get into. The middle two domains are more newer. They're pricing and the disputes domain. But we'll start at the top. So we've had a lot of flat files, as I'm sure everybody can relate to. coming into our systems. And that was a very big bottleneck for us eventually. Like starting at $0 of payments is not a big deal, but when we get to like the gigabytes of files processing per day, that gets a little bit of a bottleneck. The other thing that we had is the compute layer. So 13 years ago, we were a Ruby on Rails shop. We still are using a lot of Ruby on Rails today. So all the compute, well, 2 of the 3 computes are Ruby on Rails. And so that's like an online transaction processing system that we kind of use for like this hybrid online-offline flow, which leads to the next layer, which is our databases. So most of the databases in this diagram are Postgres. I think all of them are Postgres, actually, in this diagram. So we're using like an online database to do some of these offline processing jobs. And very quickly, we got into a lot of scaling issues around the active record, especially on the left-hand side in funding, that we just ended up dropping down to like raw SQL to process the files and to do queries on the data every day. And then we also quickly ran into space challenges. So this is why the one on the left side is kind of branching out into 2 different archive strategies. We have the archive and we have the icebox. The archive is where things go. If we need to query it again, the icebox is where we go where we don't want to query it anymore. So we kind of had to manage this like whole archiving and icebox strategy by hand. On the second domain, we just have the primary. It's not sharded. None of these databases are sharded. So it's all one giant instance of Postgres. And then we recently started archiving that directly into S3. And the disputes domain, kind of simpler. It doesn't have that kind of constraint with it. Another thing I'd like to mention on the compute side is we're getting like gigabytes of files. We've had to hand write a lot of the ingestion, parallelize it in Ruby, or drop down to other languages like Rust to kind of interop with Ruby and C to try to process those files quicker. So we've had a lot of challenges getting data in. We're essentially a data platform being built on Ruby on Rails at this point. So that's why we had to take a little bit of a look at this architecture, a critical look at this architecture, and if we could find a way around getting flat files every day, that could be very interesting. Let's see. This slide is just kind of recapping what I already kind of talked about. The challenge is we had a lot of architecture choices that made it hard to scale. We're running out of disk space. And we really wanted to get to a place where we can do more real-time processing, less of the parsing and dealing with huge files. And so we started thinking about how we could do that. We were using Kafka. There are some domains that were using Kafka in between our systems to kind of process data in real time, but nothing externally, nothing from an external partner. And so we started looking at what would it take to do that, or what we could take to get to a real-time data processing pipeline. And we looked at the different goals for that and the different benefits of it. The batch processing gives you something more like finite, but it involves sometimes hours of processing, minutes of processing. And it's good in the happy path if everything works. But if something starts failing, that's when you have a challenge, because if it takes hours to run one batch job and it fails, you have to restart from scratch. Now you've lost an hour of processing. And we do, the most critical jobs of our pipeline need to finish roughly within 3 or 4 hours of when we would get the earliest file, because we have to make bank cutoffs. So we're continuously pulling data in to pay our merchants. And so if we miss a cutoff, then the merchant doesn't get paid to the next day. So it's very mission critical to get these files parsed, and we get calculations made, and we push it out to our banks. So stream processing enables real-time insights. And so that's what we're constantly trying to get to, a place where we can go faster, get a faster feedback loop, and resolve problems faster. So as Colleen was saying, we had to transition third-party vendors. We were lucky enough that they offered a Snowflake data share to query, and we kind of jumped at trying to figure out what that would look like. Initially, this looks very much like the first slide, because we just plugged out of the flat files and put in a data share. That was kind of intentional because we were also under time to market pressure, which we needed to get everything migrated over within 1 year. And so we couldn't rewrite everything from scratch necessarily at that time. So we plugged in a partner data share instead of downloading a file from SFTP, but that gave us a chance to get our feet wet with Snowflake. We hadn't used Snowflake before. It gave us a chance to kind of build some of our infrastructure chops. So we started using Terraform to roll out the SQL code that went behind the data share, the task that queried for the data on a schedule. And we were able to shim it into a flat file, a CSV file that we could parse. We knew we could parse very easily and get it into our core computing layers without too much disruption. If we were trying to rewrite everything from scratch, which I'll go through in a second because we actually are doing that, it takes a much longer journey. So we knew this was kind of an intermediate step of where we wanted to be, but it gave us enough visibility and exposure to Snowflake to be confident in the next step of our journey. And so that's optimizing the platform and transforming it into something that is more Snowflake native. So we wanted to make sure that we solved all of our problems in the beginning, which was starting, scaling, physical disk space, time to process all the data, and also developer experience within the system. The data being spread across 3 different domains opened us up to a data governance kind of nightmare where we were teams, our offline reporting teams were using our SOR records from our Postgres database. It was in a data lake, and we had no clue what they were using. We could not change things necessarily in the Postgres database without alerting them. So it was very tightly coupled all the way down the stack, which hurt our ability to kind of iterate on the online systems. So we kind of wanted to take a more data-centric approach, a more data platform approach to what we were doing. And so we kind of inverted the architecture a little bit. So we still have the partner data shares, and whoever can give us a data share, we'll take it. We'll pull that into the production workloads as fast as we can get the data. But at the same time, if we need any data from any upstream domain, so funding, pricing, disputes, our online transaction processing system, we stream it into our production workloads. And within that production workloads, it's a kind of black box, but there's a lot of streaming that goes in. We pull in all the data from our domains from Kafka into landing tables. Those landing tables then drive Snowflake streams, and those Snowflake streams are reactive to the data in there, dropping them into tables. And then we run our pricing engine and our calculation and aggregation on top of that. And these domains still exist because they still serve purposes. So for our funding domain, it still controls all of our communication with our banking partners. So we do send aggregates up to that domain, and it pushes out to the banking partners. So that kept that logic isolated to just banking partners, and they can use aggregates instead of having to worry about all the transactions that we process. Pricing is very similar. They handle a lot of the pricing compliance aspects of our flow, and so we kept that there as more of an online system. And disputes as well. They have an online disputes API. So we kind of tried to make it so we had the online layer and the offline layer, and then process things in real time. In the last section of the data contracts, Kalyan hinted on this earlier about Iceberg. We started having actual contracts that were documented to share with our offline teams, which helped enormously when they go to do the reporting and build off of those contracts, and we can have it documented. We can have SLAs around that, and we know the data that they're using. So anything to the left of those data contracts, we can kind of iterate and change without impacting what they're using, and it kind of gives us that abstraction layer in between the teams. And that, I'll let Kalyan talk more about the centralized reporting and analytics.
When it comes to centralized analytics and reporting, it's just like your crystal ball. You're looking at your crystal ball and you're trying to figure it out what's going to happen next. That's pretty much on the analytics side. I'll talk about the reporting part of it in a bit. But if you look at the current state of it, there are multiple solutions that are available across the networks and partners and third party. So you're gathering data from various sources. This is something that everybody would relate to. In various industries that you are looking at, you have multiple upstreams. The data could have come from every other source. There are different SLAs that you are dealing with, but how do you normalize it? But by the time you present it back to your customer, it has to be normalized, and it should seem like not a stitched up Frankenstein, but actually a human working around it, right? That's the beauty of what we are trying to do. And the big part of it is how do you transform it? How do you internalize it? How do you ensure that your internal reports and your external reports are all aligned? When I talk about internal reports, it goes back to your audits and whatnot. In external, you're actually trying to do money movement. You're putting at a stake of almost that $900 billion that I was talking earlier in front of it. What we have eventually resulted in is we have tried to come up with an insights platform, unified platform, supporting all the near real-time insights. So what it would help us is that these dashboards would help us to give us a better understanding is what is happening to our data. Is there a delay? Is there a delay in what we have promised to our merchants? Is there a delay in our upstreams? Any of these pieces, we are able to ensure that we are able to alert. It is pretty much kind of a open glass box monitoring tools that we have built on top of it as this data comes in and moves in forward. It also helped us to make all these decisions way better. Now, the next part of it is we need to build these systems as scalable as possible. We talked about it in the initial part. We probably solved it very well in one of the geographies like US, but we need to replicate it across everywhere, whether it is markets that are in APAC, whether it is EMEA. I think North America, we have done fairly well. How about South America and so on? All of these pieces we are trying to solve. That means you need to have these systems that are scalable. See, there is another part of it. Many times we get caught up whether you want to build or buy, right? We all run into this problem as you are looking at this commodity hardware. There is a limitation that you will have in the data that you're going to store. We are talking about billions of transactions. So billions of transactions gives you billions of payments, and every payment, there is a story behind everything. As the story could be as close to you, it is as close as, hey, it's a flight ticket that I'm going for a conference, or it can be a salary for somebody else for their livelihood. There is a story behind it. There is a lot of analytics that you can run. There is a lot of story and a context that you are building against each of these personas that you have. And what we are trying to build is these predictive models that will help your business altogether. How do you build these scalable systems that are agnostic, and how you can scale it and replicate it, a logic that you have built it out in one market, can you replicate it in different markets? And it is not straightforward either, right? I'll get into some more examples why it is so difficult, why I was talking about why cannot I replicate it into other geographies so seamlessly. But our intent is, let's keep the data contracts intact in such a way that you can take it and replicate it to the best of your abilities, and with some amount of tweaking here and there. Now that's where your predictive models comes into picture. How you start forecasting your business. Think about tariffs that are going to hit it. A country that has started a tariffs can have a ripple effect on other parts of the geography, right? Something that has started in Europe can have a ripple effect. A war somewhere else can have a ripple effect on it. So there is a fee that is changing. There is a cost that everybody has to bear, and every company has to understand before they start going and reporting to Wall Street what is their P&L even looks like. That's what we are trying to enable in terms of our predictive models. We are trying to take all these insights and trying to map it back. What is it going to cost us? That's our journey that we are going towards. It also involves things like, how do you go back to the networks, right? There is always these networks like Visa, MasterCard, Discover, all these credit card networks, they keep on changing their fees and whatnot. How do we tap into those details? How do you tap it back into a way that it's meaningful and an insight that people can take it back? That's pretty much on this part of it. This is one code that I wanted to bring it back. One of our entire migration or this transformation that we looked at it, our biggest win is we reduce latency. The data is available almost everywhere, and it's a huge improvement. The reason why we call about it is, if you take it an ETL process, people tend to look at is extraction, transformation, and loading. What we have focused extremely on or build out these data contracts, the transformation part is still needed. There is no way that we can avoid it. But extraction and loading is what we have compressed it because of our data contracts. Now, if you look at it, it's a hub and spoke model we have built up. So data is centralized at a point, and everybody can start reading out of it from the spoke. That's what it helped us predominantly to get to that. This is one thing that we wanted to end up with. We talked about all the rosy pictures of it, right? There is always rainbows and unicorns, but there are also lessons learned that we have done all across. In our integration, in our journey, we made our mistakes. And there are also pieces where we felt there are better things that we can do. Things like transitioning from a typical stack, which is a frontier, mid-tier, and a database. This is a typical stack that you typically look at. You suddenly start changing it from that stack to a completely streaming app. It requires a lot of engineering mindset to be changed. When I say engineering mindset, people are mostly married to particular languages. They are adopted to these tools and so on. And that change in mindset is actually a bigger blocker for us. And that is something that we have to work on. Then there is a seamless development ecosystem. Now, previously, if you look at it in a typical big company where there are frontier, mid-tier, and a database, this constructs all together, an MVC pattern, you get tools out of the box. You get CI/CD pipelines out of the box, everything around it. It was not the case. We have to build it up. There is an effort that went into building up of all of this. There is also data governance that Corey talked about a lot about it. How do you ensure that whatever contracts that you are putting in, how do you stand by it, how do you validate it, and so on. All those necessary bells and whistles is what we were building it. Dashboards was another thing that we have to invest a lot in building up all of this. Other things that we also struggled with was like things like integration with Datadog, which did not come very natively through this platform. Things like PagerDuty, we have to work through all of these things. We were able to make it work, but had it been seamless, it would have been a better experience altogether. There are other things that we have to relook. Probably some of it is our own internal death, how we had data pipelines that are there, how we have flushed it. There is legacy of years together that we cleaned up. Those were our internal learnings. Coming to the conclusion, what we did predominantly was the moment we moved to a near real-time data sharing, it actually unlocked quite a lot of it. That's what I was talking about, a hub and spoke model. The moment you have your data contract stabilized at the center of it and everybody is reading of it, there is less amount of loads and transformation. You can do transformation for good reasons, but can you consolidate a transformations to a centralized aspect? That's the biggest challenge that we pushed ourselves. And if once we are able to achieve that transformation into a centralized location, loading of data was very easier, whether it is for internal aspects, external aspects, for merchants, whether it is for internal auditing, finance reporting, Wall Street reporting, does not matter where your data becomes much more centralized and cleaner. We optimized engineering resources through Snowflake Iceberg. I think there is a session on Wednesday about Iceberg, how we have used it practically and deployed it in production, how we are. Anytime you're trying to use a technology like Snowflake, it is always better to use something that is backed by an open source. That's where we have done some amount of investments around it. There is a nice, good session. Devendran and Corey are doing it in few days. Then there is a centralized analytics and better insight to reduce ETL loads. That's what I was talking quite a bit in this session. If you look at ETL processing, I think our takeaway is what is killing you? What is the biggest pain in ETL, whether it is extraction, transformation, or your loads? Try to optimize on which parts that you can. Actually, you can do at least 2 of them you can optimize. It depends upon your use case, which one you want to optimize. We optimized on transformation of data, but take a look at your own business use case and try to see where you can optimize. We started scaling of your models. We thought through of investing into engineering about saying that every time this commodity hardware comes up, there is a limit to Postgres. After that, what? You go to Redshift. Still, there is a limit to it. What do you do? Still, you have to do things like cold storage, storing it into Icebox, bringing it back, and so on. That's good, but there is a cost to it. That means every time you're defining a table, you're going to figure it out what is your strategy around it. we wanted to reduce it. So it's again the problem of build versus buy, and you can be a little more intelligent about what you're going to invest on. That was our biggest learning that we could take away. Now we are also leveraging AI and ML models to start looking at how do you build out this personal persona. I'll take an example which we are trying to work out, a real use case. Let's say every day morning at 9 a.m. I like to have my coffee. Does not matter whether I'm in Austin, whether I'm in New York, whether I'm in San Francisco. What if people can figure it out based upon my calendar, where I'm sitting, and if that comes up, that Starbucks coffee comes to me. That is doable because now you have enough insights into the people, how they are moving things, where they are based upon their calendar. You can stitch them together. That's what we are trying to stitch together all together. Those are the use cases that we are thinking about. Let's say you have a next conference in Austin in next month. It's going to be hot in summer. People should know what my preferences are, what my clothing preferences are, what kind of colors that I like to wear. And based upon it, can I start suggesting commerce around it? Can I start getting my feed around it? Answer is yes, we can do it. Not only payments, we can extend it to commerce to it. That's it.